Everything you need to know about moles, not the furry little mammals that live in Britain. Avogadro's constant. Roll the graphic. Welcome back, I'm Paul, this is Science That Sticks. In this session I'm going to be talking about moles, not the little furry mammals that dig underground around the world and mainly in Britain. I'm going to be talking about Avogadro's constant. Avogadro's constant is this idea that if you have 1 mole of a substance, you have a set amount of particles, or you have a set amount of things. The best way to think about this is it is simply a number of that many things. So for example, if I have a pair of things, I have 2 of them. If I have half a dozen, I have 6 of them. If I have a dozen, I have 12 of them. Easy so far. We use those terms in common parlance in the UK and probably around the English speaking world as well. But Avogadro's constant is quite massive. 6.02 times 10 to the 23. That means it is a 602 and then another 21 or 20 zeros behind it. So it's a massive number. And the reason it's massive is because atoms are so damn tiny. They really are. So how does this equate to concentrations and when we are writing and talking about moles in that amount of substance? And when I say that amount of substance, we really are talking about this number of particles, molecules, compound, whatever's dissolved in the water, and it just goes on and on. So let's have a look at some examples and where it could be useful. To understand the mole, it's a conceptual jump. In the same manner that I mentioned, a pair is 2, half a dozen is 6, and a dozen is 12. 6.02 times 10 to the 23, this massive number is 1 mole of substance. And when we are looking at it in terms of particles or atoms, the best thing to do is to look at carbon-12. Carbon-12 is the most stable carbon isotope, and we could get pretty much exactly 6 protons and 6 neutrons in this most stable isotope. But that doesn't really help us. What helps us is to visualize the fact that if we have 12 grams of carbon, we have 6.02 times 10 to the 23 atoms of carbon in that 12 grams. Now, when we are considering moles, you need to know 2 things. You need to know the mass that you've got and the relative formula mass of the substance that you're trying to find the number of moles out. So here's how we do this. Let's take sodium chloride, a salt. By adding the RFMs together, the RAMs to make the RFM, 23 added to 35.5 makes 58.5. So that happens to be our relative formula mass. Now if we want to find out the number of moles, we take the mass and we divide it by the relative formula mass. Pretty easy stuff, pretty standard stuff. So if we happen to have 5 grams of salt, which you can measure out in the kitchen, and we divide it by 58.5, that will give us roughly 0.085 moles of sodium chloride. It really is that simple. It's not difficult. Give yourself a couple of practices. There's loads and loads of examples out there. Practice, 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 as I've always said. And that's it. Until next time, stay cool. Goodbye.